right? So it's using a Renko bar here, and it's pretty simple. This is a 2 SMA, and so when the SMA starts sloping down, go short. When it goes flat, flatten the position, and then basically whatever direction the SMA angles towards, then take a trade. And then if the SMA flattens, then flatten the trade. Yeah, it's pretty straightforward there. All right, so I do have a chart set up here. It looks pretty darn close to that screenshot. Again, just to kind of illustrate again what the system requirements are, right, is once the moving average angles up, right, so on this bar, going from there, going up, there we go, right, the SMA is angling up, so generate a buy signal. And then when the SMA flattens out like so, right, then we'll generate an exit signal, right, an exit signal to flatten the long position. And then we can see once again, eventually the SMA angles up, so generate another buy signal, and then the SMA goes flat, so we'll generate a flat signal. All right, and then eventually we now have a down slope, so we'll generate a sell there, and then we can see immediately afterwards, right, there's then a flatten or an exit signal there. So, all right, pretty straightforward there. All right, so let's get BloodHound open. So since we're looking at a moving average and we're looking at the angle to generate the buy and sell signals there's a couple ways we can do that. Let's try using the inflection solver first, but the inflection solver will have a problem here that we'll be able to see in just a moment here. Actually, maybe not. All right. So that moving average is just an SMA 2 period. So let's set that up. Okay, yeah. So as I kind of expected here, right? So when the SMA eventually, reverses direction, reverses up, there we go, we get along. But here the SMA goes flat, and it's not inflecting up, right? It already inflected up back here. So it just went flat, and going from flat back to up, that's not the definition of an inflection, right? So we're missing, these secondary longs and shorts here if there's a flat in between here, right? So we can see right here, right? We would expect to see a short signal after this flat period as well. And let's see here. Yeah, the inflection solver doesn't quite yet have the ability to include a flat angle to broaden the definition of an inflection, right? All right, so we're going to have to go with the slope solver here. So we'll connect that in. All right, let's name it, and then let's go in here and adjust the period of the SMA to 2, right? And so this obviously catches every bar where that SMA is sloping down or sloping up. However, we want this, well, actually, yeah, you know what? This actually will work okay. With this particular system, having these extra entry signals is okay, because remember, the system buys and it stays long until it goes flat, right? So this system is always in a buy or a sell until the SMA goes flat. So yeah, so this would work out fine here if we just kind of left it like this. But most people probably would like to see something cleaner. Us humans like to see see things, cleaned up a bit. So we can do that if we really wanted to by using the signal blocker. Where is it? There we go. Signal blocker. Like so. And the key is we just need to figure out, what kind of, how long do we need to block for? Given these are Renko bars here, I can't imagine you'd get more than 50 bars in a row, right? That should be good enough. All right, so when we look at it, there we go. So we get a short, and this short's missing, so we'll take care of that in a moment. And then we get a long, right? This secondary long is missing, and we'll get to that in a moment here too, right? So to get this secondary long, that secondary long and that secondary short, we need to go in and adjust the resets here, right? Right now, we have a reset only when there's an opposite signal, right? So if you look, we get short, long, short, long, short, long, short, long, right? They're constantly alternating. That's the only way that the signal blocker will reset itself, is with alternating signals there. So what we also need is input no signal. So if we turn that one on, now there's our secondary short and there is our secondary long, right? So again, remember the reset that we just enabled is input no signal. So let's look at the signals, right? And so everywhere that we go flat, right, there is no signal, right? So again, right, we're using a slope solver. So when this SMA goes flat, then there is no slope, so there's no signal. So all of these no signals here, right, are when the SMA goes flat. And so we can use that no signal as the reset for the signal blocker. Right, so let's just connect that up, and there we have it. So that's the entry signals. Pretty simple, pretty straightforward there. And let's actually get rid of this inflection solver since that didn't work out for us. So let's delete that. There we go. And let's see here. All right, there we go. It's called the Renko SMA slope entry. There, so that's our entries. And now let's build those exit signals here, right? So whenever that SMA goes flat. Yeah, so I'm going to create a new logic template. So let's go to the logic tab here, and here we can add a new logic template there. So these are going to be our exit signals here. There. And let's see, I think I can actually use the slope solver here. I'm just going to play around with this here for a little bit, and I'm going to invert it. Yeah, there we go. And so when I invert it, what we're interested in are the bars that have a long and a short output together, right? So whenever that SMA goes flat, we get a long output and a short output together because we inverted it, right? So if we turn off the inversion, right, basically these blank bars here, right, these bars that had no output had a long and a short. That's what an inversion is, right? So let's invert that there. And now we want to isolate the bars that have both a long and a short, and we want to get rid of, right, we want to remove the long only outputs, and we want to remove the short only outputs. And we can do that using a function node, and we can use the long short modifier. Like that, connect that here. And the mode, there's a couple of modes that'll do this. We could use minimum. Minimum will do that. See, there you go. We could also use product, right? That's multiplication, right? You get the same result. Lots of ways, but I think most people probably think of minimum there. And I will name this here. There. So I like to just name the long short modifiers whatever mode they're set to there. And so there's our exit signals, right? So since we have a long and a short output being used for exits, that means that these will exit any trade direction, right? It'll exit a short signal and it'll exit a long signal. So yeah, we got all bases covered there. And then let me just erase my drawings there. And that was it. We're done.